is Mr. Moran, fourth grade teacher at AV Cato Elementary, and I'm going to show you a little guide on how we do division in the fourth grade. If you haven't watched the multiplication guide video, please stop this video and watch that one first, as I think that will really help you understand how we do division, all the principles of multiplying by two digits and multiplying by multiples of 10. A lot of that carries over into what we do in division. So if you haven't watched that video first, please do so. If you've already seen that video, hopefully it helped and hopefully it made some sense. And then strap in, and here we go with division. Now, the first thing you should know about division is we have what we call friendly numbers. These are numbers that are easy to multiply by a single digit, or we feel our students have an easy time multiplying by a single digit, and they will help them with division. So our students by now know their friendly numbers are 100, 50, 20, 10, 5, 2, 1. And if you look, obviously there's a pattern there going from the bottom up of a 1, 2, 5, and then by factors of 10, 1, 2, 5, and then up to 100. So these are numbers that are going to help them with the division process. Our first division problem is a really simple one. Most students could probably do it just in their head with their multiplication facts and their fact families. But just for the sake of an example, we're starting with that. And what we teach the students to do is take the 6, which is the divisor, the number that we're dividing by, and draw that many ovals, leaving room underneath the dividend, the 72, because that's where the bulk of their work will be shown. So these 6 ovals represent the divisor, the 6 groups that we're dividing by. And what we do is we take the largest friendly number possible that we can place in each oval and do so. So obviously 100 is far too big because our divisor is only 72. Our dividend, I'm sorry. So 100 is far too big. 50 is far too large. Even 20, we teach the students to work this out in their head. 20 times 6 would be 120. Therefore, it's too large. We don't have 120 to distribute. We can do 10, however. So we put 10 in each oval. And when we multiply 6 by those 10 that we placed in each oval, we get 60. And we're going to subtract that from the dividend because that's what is left to divide. We now have 12 after we subtract. We cannot do 10 again. That would be far too much. 50 would be way too much. 2 would it work? 2 in each group, in each oval, gives us exactly 12. And so when we subtract and we get 0, we are done. And what we teach the students is the answer, the quotient, the answer to a division problem is the sum of the numbers in a single oval. So in this case, it's just simply 10 plus 2, which is 12. Sounds simple enough? Let's move on to a bigger problem. 168 divided by 4. So again, this is what the students would encounter with their blank piece of paper. We teach them, if they wish, they can write their friendly numbers. Again, following our 1, 2, 5 pattern. And I'll draw my 4 ovals. Make them ovals so that we have enough room to write all the possible friendly numbers that will end up going in them without making it too messy and too chaotic. So 168 divided by 4, we can't put 100 in each group. We can't even put 50, as that would be 200. We can, however, put 20 in each group. So I'll go ahead and do that. And 20 times 4, we teach the students for multiples of 10 to cover the 0. So it'd be 20 times 4. And this they should be able to do in their head. They cover up the 0, and it's 2 times 4, which is 8. And then they bring that 0 back. So that's 80. And when we subtract, we get 8. And 16 minus 8 is 8. And one thing we're trying to teach the students is just because they've used the number once inside one of these ovals does not preclude them. It doesn't prevent them from using it again. So if they see that the number they've subtracted from the dividend is smaller than the difference, then the answer they get after they subtract, in this case the 80 is smaller than the 88, they should recognize, and they know right away, they can use that same number in each oval. I can use the 20 again and subtract 80 again because that 88 I knew right away was larger than the 80 I got from those 4 20s. So 8 minus 0 is 8. Now I certainly can't use the 20 again. I can't use 10 again. I can't use 5, as that would be 20. I can use 2 in each group. Excuse me. And 2 times 4 is 8. And I'm done subtracting. And once again, the sum inside one of my ovals, 20 plus 2, 42. That's the answer to my division problem. 168 divided by 4 equals 42. So let's do another one. Here we go with a little bit bigger dividend. Write our friendly numbers again. And if your child feels like they know them and they don't need to write them, once they've demonstrated that they've mastered it, we don't ask them necessarily to write them each and every time. So 387 divided by 5, I can't do 100 as that would be 500. That's far too much. But I can do 50. So 50 times 5. Students should know, cover the 0. 5 times 5 is 25. And when I bring that 0 back, it's 250. So I'll subtract. 7 minus 0 is 7. 8 minus 5 is 3. 3 minus 2 is 1. I can't do 50 again. I can, however, do 20. 20 in each oval is 20 times 5, which is 100. I subtract, and I get 37. I can't do 20 in each oval again. I can't do 10 in each oval, as that would be 50. I can do 5. 5 times 5 is 25. I subtract, and I get 12. I can't do 5 again. I can do 2 in each. 5 times 2 is 10. And I'm left with 2. The students should know if the number they have left to divide is smaller than the dividend, in other words, than the number of groups that they have, they are done dividing, and that number is the remainder. There is not enough to put in each group and have them remain equal groups, which is what division is. It is equal groups. So I add up what I've got in a single group, 50 plus 20 plus 5 plus 2. That equals 77. So my answer is 77, remainder 2. I have 2 left over. Let's do a couple more. 783 divided by 6. I'll jot down my friendly numbers again. Make my 6 ovals. And in this case, I can use 100 in each group. So I'll do that. You can see how this could get very, very messy if you don't take care to write ovals and give yourself enough space to write in each group. So there's 600. I subtract, and I get 183. I can't do 100 again. I can't do 50 again. That would be 300. I can do 20 in each group. And that gives me 120. I subtract again, and I get 63. I'll put 10 in each group. Make sure to cross out my 20 that I'm done with. And I'll use 10 in each group, and that gives me 60. I subtract, and I get 3. Again, my number that I can divide is less now than my divisor, excuse me. And so I'm done dividing. 100 plus 20 plus 10 equals 130. So my answer is 130, remainder 3. Now, there are some instances where some of your children who have an easier time with their multiplication facts and recognize those facts can kind of use a bit of a shortcut. And I'm going to demonstrate that here with this example. 648 divided by 6. So I'll write my friendly numbers. In my class, we've called into taking these other facts the acquaintances. They're people that they kind of know, they recognize them, but they don't see them every day. They wouldn't necessarily invite them into their home the way they do their friends. So these are the acquaintance numbers you'll see here in a second. I'll do my 6 ovals. I can do 100 in each group. And that's 600. I can't do 100, and again, I can't do 50, I can't do 20, I can't even do 10. I can do 5 in each group. And that would be 30. Subtract, and I get 18. I can't do 5 again. I can do 2 in each group. And that would be 12. I subtract, and I get 6. Now, of course, I can do 1 in each group. That would be 6. Subtract, and I'm done. My answer is 100 plus 5 plus 2 plus 1, 108. That would be the standard way to do it. But something I teach my students, again, those acquaintances, is to recognize when they have a fact family, a fact family that they've learned, when they have some of those members and just one of those factors missing. So if I started again with my 6 ovals, my friendly numbers over here. Okay, so I'll start with my 100. And when I subtract, I get 48. Now again, they can go to the friendly numbers. That's why they're there. That's what we teach them. It's what we feel they're comfortable with. But if they recognize that there's a combination, a fact family combination that involves 48 and 6, they can go right to that number, excuse me, and say to themselves, I know that 8 times 6 equals 48. And therefore, I can put 8 in each oval, even though it's not a friendly number. I can put 8 in each number, and 8 times 6 is 48, and I'm done. Because as we tell them, the fewer subtraction problems that they have to do, in this case just 2, the less likelihood there is for making a mistake, and the better the chance that they'll get that answer right. So we want to cut down, if we can, on the number of subtraction problems. But first and foremost is getting those factors right. And if they don't have the fact families mastered, then it's okay. That's why we have our friendly numbers. But if they do, they can take that little bit of a shortcut and maybe have some success with that. So we hope this has been helpful. If you have any questions, please don't hesitate to contact your teacher. We just ask your patience. It's a different way of doing division than we learned. I'm sure it's a different way of division than you've learned, but we think it'll help your child be successful in math. It helps with doing mental math, and we think it's going to help them on their way through middle school and beyond. So thanks again, and feel free to watch this again and see if that helps.